Hello and welcome back to Mr. Powers Teaches Algebra. What am I doing here? What am I doing? Factoring quadratics, quadratic polynomials? Okay, that's what we're doing. So let's talk about factoring quadratics, quadratic expressions. So what is a quadratic expression? It's pretty much a polynomial. And here's again a review of the definition here. It's a polynomial of order 2, right? So in other words, it's where we got the x squareds in there. So here's a definition of a polynomial. Here are examples of a polynomial. I've gone over this before, of polynomials, that is. I guess I could have given more, but really the coefficients, like here, the 3, the 2, the 5, those all have to be real numbers. And the powers on the variables have to be integers, non-negative integers. That's our definition. So a quadratic is anything with an x squared or lower power of x. So that's a quadratic. This is a quadratic. And out of those two, those are my two quadratics. I got the x squareds. All right. So what about factoring those guys? How do we factor those guys? And are they all factorable? They are not. Some of them cannot be factored. But some of them can. And so, of course, those are the ones we're worried about. We're worried about all of them. Factor it if we can. If we can't, say nope, can't factor it. So what do we do? First, it's really important to maybe take a look at some examples. So I'm going to do one example with you guys, and then we're going to try to look for some patterns here. So let's just say, first off, I had 2x minus 3 times 3x plus 5. It's like a good one to do. And what if I had to multiply that out? Just, I want to see, what am I going to get when I multiply that out? And I'm going to go down here. So remember, to multiply these, we distribute. So the 2x times everything, and then the negative 3 times everything. So I'm going to do that right now. 2x times 3x is 6x squared. 2x times 5 is 10x. Negative 3 times 3x is negative 9x. Negative 3 times 5 is negative 15. We multiply all that out, combine like terms. I got a 10x and negative 9x. I can combine those, and I get 6x squared plus 1x. 10x plus negative 9x is 1x. So I'll just write x minus 15. So I multiplied. I might be able to say simplified. I made this look a little bit better. But if I wanted to, I could factor it. I could rewrite this expression, 6x squared plus x minus 15, as a product right here with these two factors, 2x minus 3, 3x plus 5. And so our goal is to get there. Get to where, okay, how can I go backwards in this process? Instead of multiplying, divide them apart, break them up. Just like you would take 12 and rewrite it as 2 times 2 times 3. I know how to do that. I know how to do it with numbers. Can I do it with these expressions, these quadratic expressions? Can I do that? We definitely can. So let's, and for some of you guys, it might be review. Hopefully it's review. But if it isn't, let's see if we can find some patterns here. So hold on a second. I'm going to do a few more of these, and then we'll see if we can find some patterns. Okay, and so here is a few more examples. And so I want to look at these, and we want to see if we can see some patterns. Because what do we do in math, huh? We're looking for patterns. Looking for shortcuts. Do things the easy way. Find a way to work backwards. I mean, that's what we're doing. So can we take these products? So we multiply these out. This is what I get. I multiply x minus 2 times x minus 3. I get x squared minus 5x plus 6. I got the step in between. I multiply 3x minus 4 times x plus 2. And I get this, a step in between. X plus 4 times x minus 7. I get this. And then combine like terms again. The negative 7x plus 4x is negative 3x. There's my end result. In factoring, remember, we want to go the other way. We're not multiplying, we're doing the opposite. We're breaking it up into factors. Some might say dividing. So I want to go from this expression to this one. We're going to do that a couple ways. We want to see some patterns. I'm going to point out all the patterns I see and then see if we can't use those to actually do complete our goal. Here's a really, really fascinating thing that you'll notice, and with some effort, it's really easy to convince yourself or prove that this always happens. What's really, really fascinating is if you took 6x squared times negative 15x. What's 6 times negative 15? Guess what? That's 90. What's 10 times 9? Right here, 10 times 9. Also, okay, that's weird. What about this? 1 times 6 is 6. Or if I even went further, x squared times 6 is 6x squared. Negative 3x times negative 2x. Hey, guess what? That's 6x squared also. Wow. Weird. Does it keep going? 6x times negative 4x is negative 24x squared. 3x squared times negative 8 is negative 24x squared. Okay, that's fascinating. And then same thing here. Negative 7 times 4 is 28. 1 times negative 28, 28. Okay, you can see this all over the place. And that's something I could use if I really wanted to. And I can kind of see that here. Like if I was going to do this, right? I got my 5x, my negative 5x, and then, because what else do I notice? Actually, the other thing I notice is that what is negative 10x, or 10x plus negative 9x, that equals x. They add up to this middle term. These guys add up to that middle term. These guys add up to the middle term. And they multiply to the same thing that these multiply to. Because remember, those don't change. These add up to the middle term, and I already made the point that if you multiply them, it's the same as what these multiply to. So we got a lot of patterns here. All right. So what I'm kind of pointing out, but I'm doing it very loosely, and if I wanted to, I could take this and use it, and I may make a video. But for now, I just want you to realize that if you wanted to, you could go from here to here with a little bit of work. For instance, and then here to here, you could just factor by grouping. Factor by grouping would work because now you got 4 terms. That's one method that's very popular that some people love to do, is to set up this x. I can do a better one than that. We can set up this little x. We can put this, the product of these two up here, so 28x squared, and the middle term right here, negative 3x. And then what you want to do is find two numbers that multiply to the top, add to the bottom, which obviously, like, what do you multiply to get 28? 1 times 28, well, that's not going to get us 3. 4 times 7, oh yeah, 7 minus 4 is 3, so I could do 7x and 4x. Let's see, I want to add to the bottom, so negative 7x, multiply to the top. So these guys are right here, right? Okay. Multiply to the top, right there, and they add to get the bottom. Right there, you add them, you get to the bottom. Okay, so that's so you can play this game where you're like, okay, can I find two factors of the 28 here by multiplying these two, put it on top, take the middle, put it on bottom, then find two numbers that multiply and then add. Well, I could rewrite it, then factor by grouping. That's one way to do it. I'm not going to do that. But if anybody really wants me to make a video on doing that, I can, and we could do some examples like that. It's slow, and that's why I don't want to do it. And at this point, if you're not willing to use the guess and check, which is the faster more efficient method, then I think might as well use a calculator. I don't know, because they're both, but I can show you. So what's one more thing we notice? No matter what, what does the 4 and the 2, they're factors at 8. So the last two terms in our factors are factors of the n term we started with. And then the first two are factors of the beginning. That's the biggest thing. And just noticing that will make this doable. Maybe I can use the highlight just to show you. 2x and 3x, that's a factor of 6x squared. And negative 3 and 5, those are factors of 15. And that's always true. There's a lot of patterns we notice as we look at these. Negative 2 and negative 3 gets us negative 6. X and x give us x squared. So we see these patterns. I keep doing this. X and x is x squared. 3x and x is 3x squared. And then lastly, negative 4 and 2 gives us 8. 4 and 7, 28. So we see these patterns too. So that's another method. Just guess and check. And that's the way I'm going to do it with you. So let's do some examples and get this kind of guess and check. But if you notice these patterns, especially with this one, negative 3 plus negative 2 is negative 5. Negative 3 times negative 2 is 6. 4 times negative 7 is negative 28. 4 plus negative 7 is negative 3. When you don't have anything in front of your x's, this works. So if you have just x squared, you see there's kind of a pattern there, and it can be a little faster. But anyway, let's go ahead. Let's do some examples. So let's go the other way around. X squared plus 2x minus 15. Let's factor that. So first things first, we got some things to try. What are my factors of x? Well, guess what? There's only one way to get x, and that is x times x. Okay, what are my factors of 15? Well, 15 could be 3 times 5. Could be 1 times 15. And that's it. So which one do I want to use? 1, 15, and 3 and 5. Well, we kind of know. We kind of see that 3 and 5 and that 2, they're like, oh, well, 5 minus 3 is 2. I think I want to try that one first. So I'm going to try that. So let me see. It's a positive 2 also. So you know what? I don't know. I mean, I know I need a 5 and I need a 3. But I get a negative 15. So I know one of these need to be negative because these two multiply to this. I know I'm going to get 5 times 3, that's 15. Okay. So which one's negative? I'm going to say probably the smaller one because I got a positive here. So then I just try it. If it works, great. If it doesn't, I got to change something. So we multiply it out and see if it works. So this is my guess. I think I factored it, but to make sure, multiply it out and see if we get what we want. X times x, x squared, x times negative 3, negative 3x. 5 times x is 5x. 5 times negative 3, negative 15. Combine like terms. We get x squared. Let's see, negative 3x plus 5x, that's 2x. Minus 15. Is that what I started with? Yes. So I did it right. This is the factorization of x squared plus 2x minus 15. I feel great. It's awesome. Awesome. All right, let's do another one. Let's try another one. And I realize this video has gotten a little long, so this will do it for now. If we need more examples, I can do more. I'm happy to do them. Just let me know. So 3x squared plus 2x minus 8. Oh, so this one's a little bit tougher. First off, I got, 3x. How do I get 3x? There's only one way to do that, so that's nice. That's x times 3x. That's the only way to get 3x squared. So I know in my whatever I try, it's going to be an x and a 3x. Eights. What do I put for these terms right here? Well, they got to be factors of 8. So, I mean, for that, what we could do 1 times 8. We could do 2 times 4. That's it. So we got to try one of those. I don't know. I'm seeing this. I'm looking at this. Maybe I can mess with that. I don't know. So let's try 2 and 4. Let's try 2 and 4. Let's try. I think I want the 4 bigger. So I don't know. 4 and 2. I'm not sure this is going to work. Let's try plus 4 minus 2. Let's see what happens. All right. So x times 3x, 3x squared. Looking good. X times negative 2, negative 2x. 4 times 3x is 12x. And then 4 times negative 2 is negative 8. So how am I doing? Well, the first terms are right. The last term is right. We're always just worried about that middle term. Did we get it? We did not. We're getting 3x squared. If we add these two up, we get 10x. Okay, so that didn't work. Maybe I can switch them. Well, I mean, I get 12 and 2. Maybe if I switch, maybe if I put a 2 here and a 4 here. So let's try that. So we got to go x. We know we're going to have the x and the 3x, no matter what. But this time, let's switch the 2 and the 4. Let's put 2 over here and 4 over here, see what happens. And I don't know. Well, I know one's negative, one's positive. Let's try that, see what happens. Okay. X times 3x is 3x squared. X times 4 is 4x. Negative 2 times 3x is negative 6x. Ooh, it's looking pretty good. And then negative 2 times 4 is negative 8. Now, if I add these up, my middle terms again, my like terms, what do we get? 3x squared minus 2x minus 8. Is that what I wanted? So close. I got the 3x squared. I got the minus 8. I have negative 2x instead of positive 2x. That's an easy fix. That just means that my signs were wrong. These guys, I need to switch those. If I just switch those, I would have it. So I'm done. I know for sure that would fix it. So my answer is definitely going to be x plus 2 times 3x minus 4. So x times x is 3x squared. X times negative 4 is negative 4x. 2 times 3x is positive 6x. And 2 times negative 4, negative 8. There it is. We got it. 3x squared plus 2x minus 8. Love it. I could circle that a little better. Here we go. I can do it. I can do it. There we go. There it is. So this is my answer, actually. There's my factoring. So it took a few guesses, a few tries, but I got there. And the more you do this, the quicker you get. And you get kind of an intuition also for finding where to put these. So we knew there was a 2 and a 4. We tried it one way, it didn't work. We switched them. It worked. If that didn't work, we got nothing to work, and then we could try the 1 and the 8. Because there was only one way. We only could do an x and a 3x for the first two. All right. That'll do it for this video. Long one, but I hope you found it useful for factoring. And now we should be able to factor almost anything, at least quadratics, if they're factorable. In this case, we got everything was factorable. So until next time, enjoy doing math.